Alright, here we are at the top of page 3 for section 1.2. And the instructions say that we're going to perform the indicated operation, reduce to lowest terms. We just finished adding and subtracting fractions, and now they're going to leave it open to we need to use our visual cues for what operation we're going to be using. So it could be plus, minus, or addition, subtraction, multiplication, division. We just did a bunch of adding and subtracting. The focus will probably be multiplying and dividing in this section. I say probably, it will be. I'm giving it away. And of course you always want to reduce to lowest terms after doing a problem with fractions here. Now when you talk about a fraction times a fraction, and when you multiply, you don't have to worry about like denominators. You can just do top times the top, and then bottom times the bottom, or numerator times the numerator over the denominator times the denominator. You don't have to do like fractions. I'm sorry, like denominators. What we do need to be aware, though, is the fact that we have mixed numbers here. And it is possible to apply multiplication to every piece and get it all distributed and do all that. But I find that tends to leave chunks behind. Now, if that's your method and it's working for you, great. But again, there's a purpose for why we're doing things the way we are with fractions. It's to help us get ready for the algebra. And in that sense, it's going to be more beneficial to us right now to go ahead and convert mixed numbers, like we see here, to improper fractions first. Then we can multiply top times top, bottom times bottom. So what that looks like is, as we take 2 4/5 and go around here, 5 times 2 and then add the 4, you get 10 plus 4, or 14/5. And then in the next one, 1 1/4, go around 4 times 1 plus the 1, you get 4 plus 1, that's 5/4. And now we're multiplying here, but before we do, the parentheses help preserve that, the fact that we're multiplying. Before we do, go ahead and multiply 14 times 5 and 5 times 4 and see what we get. We want to utilize what we've learned about factorization. And in this case, you might already see that there's a 5 on top and 5 on the bottom, and you might be feeling comfortable enough to go ahead and cancel those. But I want to even show you a little bit more that you can do. The 14 also can be factored into 2 times 7. And the 4 in the denominator can also be factored into a 2 times 2. And we can actually rewrite this as, instead of 14 times 5, as 2 times 7 times 5. And on the bottom we could rewrite it as 5 times 2 times 2. Now bear with me here for a minute. Most of you can do a lot of this in your head, but what I want to show you is what the potential here is, because this is what's going to happen with the letters. A lot of this stuff you're doing with the numbers, you go, oh, that's easy, I know how to do that. That's great. What we're trying to prepare for is knowing how to do it with the letters, how to do it with the variables. So we use what we have come to know as the commutative property of multiplication. They can switch places, just like you're going to and from work. You can switch places here. This can become 2 times 5 times 7 on the top, just switching those around. And on the bottom, switching the 5 and the 2 becomes 2 times 5. I'm sorry, I wrote it different than I said it here. 2 times 5 times 2. I'm just switching things around. Make it easier for myself, because now I can break those off. I can stretch out that multiplication to see what it looked like before we combine top times top, bottom times bottom. Kind of back to this situation where you've got separate fractions. 2 over 2 times 5 over 5 times 7 over 2, and I'm kind of running into my workspace here. But the reason why I want to show you this is 2 over 2 is really just 1. And remember, we're looking at having that strategic 1. We aren't changing the value of anything. We're just multiplying it by something top and bottom that allows us to get where we want to go. In this case, we're undoing that. The 2 over 2 is 1, the 5 over 5 is just a plain 1, and then you're left with the 7 over 2. So it reduces to just plain 7 over 2, or 3.5, and I severely ran into the workspace here of the try problem. Sorry about that. Some of you may have seen that right away. The 7, I'm sorry, not the 7, the 5 canceled with the 5, the 2 canceled with the 2. You're left with 7 over 2, or 3.5. So a couple different ways to look at it, think about it. Again, if you're trying to figure out how much work do I show, I'd encourage you, show enough work on the easy ones, even if you could do it in your head, so that you're confident about the steps when the problems get harder. And they do get harder. Okay, so tell people what you, or tell someone, or tell yourself, talk it out loud, what you've seen happening here, what you're learning. Make note of any questions that you want to bring to your help resource or bring to class. And then try this number 46 here. It is a multiplication problem, so watch for that. Make sure you apply what you know about multiplying fractions, and pause the video and come back for the answer. Okay, and then we're back, so if you haven't tried 46, hit that pause button. You should get an answer of 24 over 7, or you could write that as 3 3/7. Just gonna double check how we're doing on focus. Looks great. Had a couple issues, a couple videos came out really blurry, so I'm a little gun shy now, so thanks for indulging me as I make these pauses while we go. Page 19 has the book talking you through multiplying fractions, talks about that the product of two or more fractions is the product of their numerators divided by the product of their denominators. In other words, you're going to multiply the numerators, top times top, multiply the denominators, bottom times bottom. And then really, really good. See if you can kind of force yourself to think this one through. In the algebraic language, what does that rule look like? Any old fraction, a over b, times any old fraction, c over d. These could all represent different numbers. To multiply that, you just multiply top times top, a times c, bottom times bottom, b times d. No numbers. Here's the general rule. Okay, we'll see at the bottom of the page.